Okay, so now that we know how to do half reactions, we're actually going to work on doing half reactions in an acidic medium. So today's objective is to write and balance equations for redox reactions in acidic and neutral solutions by developing simple half reaction equations from information provided about redox changes. Essentially, you are going to learn how to write more complex half reactions for when things are in a solution or an acidic solution. Okay, so an acidic medium is what we call this. So some polyatomic ions and molecular compounds go through very complicated oxidation and reduction processes, and we need to be able to actually represent those half reactions for the acidic mediums. So here's an example. We're just going to get right into it, and you can see what the issue is as we go through this example. And then we'll talk about the solution. So nitrous acid can be reduced in an acidic solution to form nitrogen monoxide gas. So if I were writing out nitrous acid, that would be, of course, HNO2 aqueous. You could look that up in your data booklet. Can be reduced in an acidic solution. We're just going to ignore that for now, but reduced means we know electrons are going to be reactants to form nitrogen monoxide gas. So I'm making NO gas. What is the reduction half reaction for nitrous oxide? So once we've done this, we probably right away notice that we have some issues. One issue is that I already have my N balanced with one on the right and one on the left, but I don't have my O's balanced, and I have nothing that I can work with to get another O on the right. Also, I have an H in the reactants and I don't have anything in the products. So that's where the acidic and solution part is going to come in. Acidic gives us H positive aqueous at our disposal, and then solution ends up giving us water. So we have H2O liquid floating around that we can use as well. So that's where we're actually going to add these to the half reactions in order to make them work. So we're going to come back to this example. Let's move on for a second and then we'll talk about it. So we're going to break this down into steps. And yeah, we got a little bit of Sesame Street just to make Mr. Kemp's class extra comfortable. All right, so moving on. Here's what we do. First, we balance atoms that are not H or O. Okay, so everything except for H and O we balance first to make sure that we have the right numbers on the left and on the right, so they're balanced by putting in coefficients. After we've done that, we're going to balance O, and then we're going to balance H. And then finally, we're going to go and balance electrons afterwards by using the charge. Essentially, this actually works by we are going from largest to smallest, right? So we're balancing stuff that probably is larger than O, and I know there might be some examples where it's not, but for the most part, we're dealing with things larger than O. Then we're going to balance O, then we're going to balance H, which is a super tiny atom, the smallest atom, and then finally we're going to actually go to electrons, which are even more tiny. So that's our procedure. So do this first, number 2, number 3, number 4. Let's see this in action now, going through the example that we saw. So I have HNO2 aqueous and NO gas. So I'm going to start by balancing not H and not O, which would be the N. That is the only other element I have. I have one N here and I have one N over here. So right now N is good. We've got N all set up. I don't need any coefficients for that. The next step is realizing that I have two O's on the left and one O on the right. So I need to get another O in the products on the right-hand side. So I'm going to use water for that. So I'm going to add H2O liquid in order to get an oxygen on the right. H2O is always how I add oxygens in this process. And now my O's are good. I have 2 on the left and I have 1, 2 on the right. Finally, I'm going to add H positives for my hydrogen. I right now have 1 H on the left and I have 2 H's on the right. So I'm going to add an H positive aqueous in order to balance out the H's. So now my H's are good. I've got 2 H's on the left and I have 2 H's on the right. Finally, I need to balance the charge using electrons. On the left-hand side, I have a charge of 1 positive, and on the right side, I have a charge of 0. I always add electrons to the most positive side, the more positive side. So that is the left-hand side. So I'll sneak this on kind of like to the left here. I'm going to add an electron right here. And now that means that I'm at 0 in both reactants and products. So my electrons are now done. So this is a reduction half reaction because electrons were a reactant for that. Okay, so let's move forward past spazzing Elmo there and try a different one. So chlorine is converted to perchlorate ions in an acidic solution. Write the half reaction equation. Is this oxidation or reduction? So leaving a little bit of mystery here of which it is. So we're going to start out by writing out chlorine. We're going to remember that chlorine, oh, I actually want to move that over just a tad so I have lots of room. That chlorine is a Hofbrinkel element, so I'm going to write this out as Cl2. We don't know if it's gaseous or aqueous. I'm going to put aqueous here. I'm assuming this is happening in solution, and chlorine does dissolve a little bit. So converted to perchlorate ion, so I'm going to make ClO4 minus aqueous, leaving lots of room and reactants to write a lot of stuff in an acidic solution. So that means that I have access to H positive aqueous because it's acidic, right? Acids are acids because H positive are in solution. And the fact that I have solution means that I have H2O liquid at my disposal. So this is how you know that it's this kind of question. When you see acidic solution, acidic medium, you know you're probably going to have to go through this process of adding waters, adding H positives in order to make it work out. Okay, so I have my half reaction started here with what I know with chlorine and then the perchlorate, ClO4 minus. I'm going to balance my chlorines first. I have 2 on the left and I have only 1 on the right, so I'm going to put a 2 right here. So again, I start out with the largest atoms, the ones that aren't H and aren't O. So 2 chlorines, that's done. So chlorine is good. I now can move on to oxygen. I have 4 O's on the right, I have 0 on the left, so I can add 4 H2, oh, sorry, 8 H2Os. Whew, that was a close one. 8 H2O liquids on the left-hand side because I have 2 times 4 is 8 on the right, so I need 8 on the left as well. My O's are now set up. Now if I take a look at my hydrogens, I have 16 H's on the left, I have 0 on the right. I don't have hydrogen there at all right now. So I need to add 16 H positive to the right-hand side in order to get hydrogen to balance out. So H positive is my source for hydrogen. Now hydrogen is good. Now if I take a look at my charge on the left-hand side, I have 0, 0. So I have 0 for a net charge on the left. And on the right, I have 2 negative from this. I have 16 positive from this. So that's going to get me to 14 positive. So I'm going to have to add electrons in order to make this equal. So I add it to the more positive side, the 14 positive side, which is much more positive than 0. And I'm going to add 14 electrons on the right here. Okay, so 14 electrons. So left a lot of room here that I didn't need. That's okay. And now I'm actually done. My charge works out, 0 on the left, 0 on the right, so it's equal. Doesn't have to be 0, just has to be equal. I have my chlorine, my oxygen, my hydrogen all good, and now my electrons are good. So now what is this? Well, I have electrons as a product. So this is an oxidation half reaction. It lost electrons, right? So that's oxidation. Okay, so that was that example. Here's another one. What I would suggest you do is you pause this right now, you give it a go, and then come back and see the solution and see if you did it correctly. So pause now. And here's the solution. So I have manganese 4 oxide, so that's going to have MnO2. This is actually a solid, and it produces manganese 2 ions. So I end up with Mn2 positive aqueous. Again, I'm leaving a lot of room here for me to put things where I need to put them. Okay, so I'm going to start by balancing the manganese, right? I've got 1 on the left, 1 on the right. Hooray, it's already done. That's amazing. Now I'm going to look at oxygen, and I'm going to balance out oxygen with waters. I have 2 on the left, so I need to have 2 H2Os on the right to make oxygen balance out. Now I have 4 H positives on the right, well, 4 H's, sorry. So I need to put 4 H positives on the left to make that work. So this is me balancing out the hydrogen. So far I've done manganese. I've got oxygen done. It's balanced at 2 on both sides. And now I'm dealing with H. I had 4 on the right, so now I have 4 on the left. That is now good. All right, so now the last thing I look at is my charge to get electrons. On the left-hand side, I have +4. On the right-hand side, I have +2. So I need to get 2 electrons on the left to make it equal. Again, I always add electrons to the more positive side, which is the left-hand side in this case. And I'm going to have to add 2 electrons in order to make this equal. So now both sides are ending up at +2 for a charge. And that's it. That is balancing half reactions in an acidic medium. So try out your practice, see how it goes. Any questions, let me know.